Solve the equation negative 3x squared plus 7x equals 6x squared minus 5x. Now, the goal for solving an equation, let's remind ourselves what it is. Our goal is x equals a number. However, since this is for our goal for linear equations, and in general it applies to this. However, when we have a quadratic equation, we have x, the variable, raised to the second power. We actually expect as many as 2 solutions. Of course, positive 1x, we want to know the value of 1x, what it's worth, in terms of the equation, with respect to this particular equation. But we're expecting one value of x and a second value of x, as many as 2 solutions for x. So what we can do, and of course, the other aspect is we could send the x's to the other side of the equal sign. X's can appear on the right side, numbers on the left, which makes these two possibilities an option. Okay, as long as we have a positive 1x, a positive 1 and a coefficient of x, then what we're anticipating is that perhaps the 2 solutions, x1 and x2, and we could send the x's to the right side to get this equation solved. So the first thing I'm contemplating is which side to send the x's to, especially the x squareds. The overall solution process for a quadratic equation that we've learned in this class is by factoring. But before we can factor, the first step is to get all the x squareds and all the x to the first terms, every term, to one side of the equation. I am going to select targeting this 3x squared for elimination from the left side, because rather than subtract 6x squared and bring it to the left, if we did, we'd end up with a negative 6x squared. If we add the smaller term and then to eliminate the x squared terms from the left side and then balance the equation out, by adding 3x squared to the right side, we wind up with a positive 9x squared. And it's just a little less laborious to have our coefficients be positive. Now, the other thing we need to do, we've eliminated the x squared term. We can go ahead and work on, in the same step, we can work on eliminating the 7x to the first power term. It's involved in addition with its neighbor, so we can use only add or subtract. If we use subtract, then if we have 7x's and we take away 7x's, we're left with 0. And so then these could be added together or subtracted from each other. It doesn't matter, because 0 minus 0 is going to end up being 0. But in the same step, before we get too far ahead, if we subtracted 7x from the left side, then we really need to subtract 7x from the right side to keep this idea of balancing the equation in perspective. So negative 5x minus 7x would be negative 12x. If I owe somebody 5x's and I owe someone else 7x's, I really add them together because I owe a total of 12x's to 2 different people. So now what we have is 9x squared minus 12x on the right side equals 0 on the left side. At this point, what we're expected to do is, let me change pen colors here. What we're expected to do is factor the left side. I'm sorry, factor the right side. Factor the right side is where our polynomial appears. The first thing that we do to factor is we look for a GCF. I'm seeing a GCF in here. If we were to factor these, there's 9 times x squared. Take it all the way down to prime numbers is 3 times 3 I'm going to leave the x's squared. Well, let's go ahead and split them up because we're going to see what happens here. And then we have 12 times x. The 12 breaks up into 3 times 4. Here's the x. I'm doing little factor trees and looking for common factors. 2 times x. So now when we look for greatest common factor, which is the first step really we should always do, is look for a greatest common factor. We see that between the two terms, 9x squared and 12x, we are able to identify a 3 in common. I look for the second 3. There's no other 3 to match for the second 3, but I see an x in common between the first and second terms. So it looks to me as if the GCF of these two terms on the right is 3x. Of course, GCFs can always be positive or negative. We'll float the sign out when we actually go to factor this completely on the right. I'm going to rewrite the right side to make it clean from our work, our scrap area work. The left side of this equation equals 0. The reason we need it to equal 0 first is that's the first step in solving a quadratic equation. Make sure it's in standard form. Now we're actually taking out, we're actually conducting the factoring by taking out the 3x, the GCF of 3x. We need to fill in these two blanks. We want the first blank always to be a positive, in our remaining polynomial. The term we're trying to bring back, like for this 3x times everything we need in this blank to make positive 9x squared come back, this would have to be a positive, so that positive times positive makes this positive. So that's what helps us select between positive or negative GCF. We float this sign out last. So positive times positive makes positive. 3 times 3 makes 9. X times, I would need another x in this blank so that x times x makes x squared. Now we distribute to the other blank, the second blank, and what we would need is positive times negative to make this negative on this term come back. A 3 needs a 4 to multiply to make 12, but we don't need any more x's here because the x is all in the GCF. Don't forget, this is only the right side of an equation. Now, if I clean this up one last time so that we can see it more clearly, what we have here is 0 equals 3x times 3x minus 4. Now what takes over is that when two factors times each other, this 3x and this 3x minus 4, when two factors times each other equal 0, we say to ourselves by applying the zero factor property, the zero factor property states that when two factors or more equal 0, one of them must equal 0. So we say that either this factor, 3x, is 0, or this factor, 3x minus 4, is 0. One of those two factors has to be equal 0 because when they times together, we get 0. Now we just go through the motions of actually solving these two little equations for x because now they're linear. These are two equations to the first power in x. So we divide this power, we divide this side by 3 so that we get our, and you see that I flipped them. We actually are coming down to these two forms. I want to make a positive 1 in front of x, so we divide the left side by 3 to get our, anything divides into itself once, to get our positive 1x. And then we balance out this little equation by dividing the right side by 3, and we get 0 divided by 3 is 0. So here's one of our solutions. Here's the x1. Positive 1x equals x1 equals a number. This guy, we're going to add 4 to both sides. I'm targeting the 4 for elimination. Look, for elimination on the left. And then we're balancing the equation by doing the same thing to the right. 0 plus 4 is 4. And then here's this, no math symbol left behind. 3x plus 0 is 3x. Here's the last step that we need to do again. We want this positive 1 for the second solution. So we divide this by 3, balance the equation, by dividing the right side by 3. These 3's, anything divides into itself once, so we get, here's that positive 1, x equals 4/3. This is our second solution that we expected. I will leave the checking step up to you, but what this looks like to me is our two solutions that we expected a maximum of, x is equal to 0, or, see here's this or that's been traveling down between the two sides, or x2, or x is 4/3. X is 0 or x is 4/3. And when we come here, I see that the proper answer choice is B. 0 or 4/3. Here's the proper answer.